Hi there, and welcome to our another video tutorial. In this particular video, we are designing and building a 3-phase control panel for a 3-phase generator or grid supply. This very particular design was done for a 3-phase generator with 5 flats or buildings, a pumping machine outlet and a security house, so that we could easily control them. As shown in this video demo, you could see us testing the control panel design. By turning on the breaker for each flat, the corresponding pilot lamp turns on. And we can also see the voltage for each phase and its corresponding current on the panel meter display device. We would go through, step by step, on how we built this control panel box. Should you find this video interesting, like, subscribe and share it. We would begin with the schematic diagram. However, you can order a copy of the schematic diagram by reaching out to us via email or Telegram or WhatsApp. Next, is the assembling of the materials themselves. For the panel box itself, we used a panel box of dimensions 100 cm in length by 60 cm in width. We began by attaching the pilot lamps to show the status of each flat. When the pilot lamp is turned on, this would tell us the flat is powered, and if it is off, the flat is not powered. And we cut out the opening for the 3-phase voltmeter and ammeter device. And we put this 3-phase power monitoring device there. There are also 22mm LED pilot lamp with digital voltmeter, each of which displayed for us the voltage of the particular phase the flat was running on. Once all of these are completely mounted, the next thing to do is to start wiring them. However, for the output and input connectors, we used this 100A terminal block. And to mount them, we used the aluminum bars to safely mount them inside the panel box. Also, the 3-phase breakers used the DIN rails. This would make the wiring easier. The connection was pretty straightforward following the schematic diagram. The pilot lamps for supply output indication were connected to the output active phase line and the neutral for their respective flat. The pilot lamps with the voltmeter, however, were connected to the input phase of the active phase and neutral. We used the power monitoring device to know the current and voltage on each output phase. Each wiring would have to be cable managed using cable ties. This would ensure that cables are not flying around. We placed the current transformer for each phase on the mounted copper bar that was conducting for each phase. And this was wired to the digital voltmeter and ammeter device. Each of the cable we used were properly lugged before fastening them to the point we needed them to be placed. And at some points, we needed to use a bot to do the fastening onto the copper bar itself. And finishing off the work with a screwdriver or a spanner or just a plier as a final resort.